Super excited to have you here, Jared.
Thanks so much for having me.
So I thought I'd ask Claude for a question to ask you. I told Claude I'm going to be talking to Jared. You know, Jared invented you. What should I ask Jared?
So I can be embarrassed in two ways.
You can be embarrassed two ways.
Claude is wrong if I'm wrong.
So it's a three-part question, and what Claude wanted to know was what originally led you to focus on scaling laws for language models? It wanted to know, did you have a eureka moment that shifted your thinking about scale? And you know, Claude also wanted to know, has that changed with test time compute?
Yeah, well, I guess, how did I start thinking about scale? I was talking to other researchers working on AI, and one of the things that everyone was saying already 5, 10 years ago was that big data was a thing. And so I kind of wanted to ask questions like, how big? How much does it help? And I would also talk to other researchers who would say things like, I trained a bigger model and it's converging exponentially, it's learning this fast. And I wanted to answer questions like, exactly how fast is it learning? How much better is AI getting? And because I came from a weird background, I was a theoretical physicist before working on AI, I was used to sort of focusing on big picture questions and trying to get as quantitative as possible about empirically measuring things and then trying to find the patterns, because that's what physicists do. We find patterns in nature. And I figured I could just treat AI the same way.
That's awesome. So I had one more question, and then we'll get on to your talk. As you see scaling laws and you see the progress that AI is making with scaling laws, what is your advice for this whole room in terms of how they should prepare themselves for exponentially improving models?
Yeah, so the main advice I give is to build things that don't quite work yet, be imaginative, try to think about if AI was a bit better, a bit more capable, what you could do, because I think that that will serve you well. As AI catches up to your imagination, you'll actually be able to make things that work, even if they don't quite work yet, and you'll sort of have a leg up by having thought ahead.
That's awesome. With that, and no further ado, Jared Kaplan, Scaling on the Road to Human-Level AI.
Great.
Enjoy.
Thanks. Great, so I'll be talking about how AI training works and how scaling laws motivate our belief that AI will get better and better, and some things that I think we're going to be building in the next few years to take AI even further, perhaps to sort of human level. So perhaps many of you are experts, but just to review, how do we actually train AI models like Claude? There's kind of two key phases. And the slide is kind of nostalgic for me. I think the first slide, the first image comes from the original GPT-3 model, which is now ancient history. And the second image comes from the very, very first environment we used to train the very first version of Claude, call it Claude 0. So the first image is showing you the probabilities that large language models assign to words, because the way that these models are trained in the first half of training, which we call pre-training, is to predict the next word in a sentence, in a paragraph, in a corpus of text. And you can see here, there's a sentence that says, as a speaker at a journal club, you're probably elephant me to say certain things. And GPT-3 was able to note that the probability of elephant in that sentence was really, really near zero. Instead, it was much more likely words. And by refining these kinds of probabilistic predictions of the next word in large data sets, we train models like Claude to understand human language and the correlations and ideas that underpin it. The second stage of training that we're very actively scaling now as well is reinforcement learning. Now, this image shows you sort of one of the very first interfaces that we used to get feedback on one of the very first versions of Claude. And all we do is ask people, is response A or B better? And using a data set of human preferences, we're able to train Claude to reinforce the kinds of responses that people find useful, that people find helpful, honest, and harmless, and discourage responses that aren't those things. Those are the two phases, and we've made a lot of progress in pushing both of them forward. So the perhaps classic scaling laws pertain to the first phase called pre-training. And the scaling laws show that if we scale up the amount of compute we use to train AI models, if we scale up the data set size we use for training, if we scale up the size of our neural networks, then very precisely and predictably, over many, 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 many orders of magnitude in scale, our models get better at fitting the data. They get better at predicting the next word in a sentence. They get better, in other words, as kind of autocomplete models. So that's the first part of scaling, and I think that's continuing. It's allowing us to make better and better versions of Claude, like Claude 4 Opus and Sonnet that we recently released. The other component of scaling is this reinforcement learning phase of training, where we train AI models to actually do useful things like write code that passes tests, perform in a helpful, harmless way, etc. And this is sort of a cute figure that's also ancient history. It's also nostalgic for me, that dates to 2021. And one of the earliest researchers to join Anthropic wrote a paper in 2021 where he was inspired by scaling laws and AlphaGo to try to see, is there scaling in something like AlphaGo? And he used a simplified game called Hex, but it's sort of the same story. And what he found was the plot that you see there. The key point, of course, is there's a bunch of straight lines on the plot. We like to see straight lines on the plot because we can continue them and make AI better and better. But specifically what he was looking at is, as he trained models to play this game of Hex in exactly the same way that AlphaGo plays Go, he saw that the rate of success in winning the game, which we often refer to as ELO scores, they're exactly the same as chess ratings. And since this plot, ELO scores have become much better known because there's a lot of evaluations of AI models that use these scores based on preferences from people to evaluate models. But this was how often these models win, and Andy found that actually these Go-playing models trained purely with reinforcement learning scale very beautifully. They win more and more the more compute you put into training. And this is something that we've seen again and again in the last couple of years as we've scaled up RL, reinforcement learning, the phase of training that makes Claude better and better at doing useful tasks. So what capabilities are we unlocking as we scale pre-training and RL and make AI smarter and smarter? I think of this as kind of a two dimensions of AI utility. One of them, the y-axis, is sort of whether, the extent to which Claude can meet you where you're at. So AlphaGo, 10 years ago almost, was superhuman at playing Go, but its entire universe was the Go board. That's the only place that it could operate, which meant it wasn't very useful. It was super intelligent, smarter than the best Go players, maybe more creative as well, but it was confined to the Go board. But as we've improved AI, we are able to train models that use all sorts of different modalities, from text to code to images, audio. We're able to train AI models now that use computers the way that we do, and we imagine eventually this is going to take us to training AI that can control robots and engage in the physical world and do everything that we do. On the x-axis, I have sort of the time it takes us to do the sorts of tasks the different versions of Claude can do. And I think that we're pushing this further and further from the kind of models we had last decade that maybe could answer a question or do something that would take us a few seconds, to models that can do tasks, that can do work that takes us minutes, I think now we're at the scale of an hour or hours. And I think if AI capabilities continue to scale, we're going to have systems that are agents that can do work that takes days, weeks, months, and eventually systems that can do the kind of work that takes whole human organizations. So that's how I think of sort of AI capabilities as kind of moving up and to the right in this kind of plot. And others have actually looked into this in great detail for software engineering tasks. So this is sort of a plot by an organization called Meter that tries to measure the capabilities of a variety of AI models and benchmark them to how long it would take people to do the kinds of tasks these AI systems can reliably execute. And again, we see this kind of exponential scaling where for each year, the length of tasks that an AI can do is doubling something like every 7 months. And various folks have sort of taken this further. There's this AI 2027 blog and discussion that you can look up that sort of tries to extrapolate this based on the idea that as AI systems get better as agents, they may be able to improve more and more rapidly. And so this was AI 2027's forecast for how quickly AI systems, through scaling and other algorithmic improvements, will be able to do more and more complex tasks that only we can do today. So I think that the reason why AI has been making so much progress over the last 10, 15 years, and especially the last 5, is not that AI researchers like me are smart, it's because there are simple recipes that you can execute on in order to make AI systems better and better. And so I think that the things that are left at this point are relatively simple. We need to give AI access to the kind of knowledge that we use to do useful work. It's not very helpful if every time you talk to Claude, you have to explain all of the background information Claude needs to know, so we need to integrate knowledge into our systems. We also need them to have their own memories, longer and longer term memories, so that they can execute on very complex tasks that take millions, tens of millions, hundreds of millions of tokens, and remember what work they're doing and coordinate across the jobs they're doing. We need better oversight of AI models. So we need to leverage the capabilities of AI to help us to supervise AI better, to make AI safer, more honest, more harmless, and also more capable when it comes to fuzzier tasks that are not just, say, writing a piece of code that passes tests, but involve questions like writing a piece of code that's actually well written and easy to build on. So we need better and better AI-driven oversight to improve this. And then we need better environments, better playgrounds, larger tasks for our AI models. We need to continue to improve AI capabilities for different modalities so that we can make capabilities like computer use and eventually robotics better. And then, of course, we think that if with these kinds of ingredients and further scale, we're going to be able to keep improving AI capabilities, but scale is still an important ingredient in where we're headed. So I think with improvements along these lines and further scaling of both pre-training and reinforcement learning, we're likely to see more and more capable AI. And so how should you prepare for better AI systems? I think, as I mentioned, it's good to spend time building products that don't quite work yet, because they will work in the future if you believe this narrative that AI is going to keep getting better. I think you should get ready to leverage AI for AI integration. I think a lot of the bottlenecks in using AI are that we need to build new workflows. We need to learn how to integrate AI effectively. But hopefully, as AI systems become more capable, they can help with that so that we can move more quickly. And I think generally just sort of figuring out where adoption is ready. I think this is extremely tricky. I don't have any crystal ball. But I think figuring out where there really are opportunities to leverage AI obviously is going to help us to be in the right place at the right time. And so if you want to learn more, obviously from other folks here, from various resources, and from Anthropic. But with that, I will say thank you.